Good evening folks, this repair video this evening is going to be on my Acer Aspire 6530G, which I've owned for probably about 8 years now. It was quite a high performance computer back in the day, but it's just stopped working recently. There's no power getting to the machine at all. I've checked the power supply. I've checked it with another power supply that's known to be in full working order, and still nothing. I have previously stripped this down, and the only I did trace out the where the power's coming in, and sort of the last point that I could find that had the power sort of terminated a fairly big MOSFET, and on the board was discoloured, and to the point that the solder mask had lifted off in places. So this is destined for the bin, so I thought I would try and source a new MOSFET and replace that in the hope that it worked. If not, I've only lost a couple of quid. So I'll show you I'll stop the video in a moment, and I will strip this down to motherboard level, and I'll show you the damage. But I did manage to source a replacement part. It's a Fairchild in-channel MOSFET, 30 volt 40 amp, and the package, it's a TO252AA-3, and you can probably see it's in the anti-static packaging there. So yeah, it's a little surface mount MOSFET. So yeah, I'll stop the video now. I'll strip this down. It should take me about 10 minutes or so, and then I'll show you the damage, and then we'll attempt a repair on it. See you in a minute. Welcome back folks. Well, that's the laptop stripped down to the motherboard now, and as you can see, I've sort of prepped the area as best I can, just using some capped on tape, just to protect the other components, especially there's some small sort of resistors and very small surface mount components, and I don't want to heat it up and for those just to fly off with the hot air gun. Yeah, so as you'll recall from the first part of the video, I said there was some damage to the solder mask on this, and as you can see, yeah, it's flaking off, and there's it's almost a dry joint on there. It's quite difficult to see with the camera, but yeah, it's almost dry joints, and it's almost sort of crunchy. So I'm almost certain this has failed. So what we're going to do now is attempt to remove this. Now before we start, I'm not an expert, as I said in some of my other videos. I'm a hobbyist, so I'll do it as best I can. It may not be perfect, so yeah, we'll give it a go and see how it pans out. I'm just using this anti-static mylar bag, just as a bit of heat protection from my SD mat, and just a bit of scrap wood here just to elevate it off the mat again, because I don't want to melt it. So we'll get cracking. I'll just heat this up a bit. So obviously there's certain sort of reflow settings and all that good stuff. You have various temperatures over various times. So I'm going to start off just above 100 to start warming the board up. What this will do is get the surrounding area to a sort of raised temperature. I'm going to go with a sort of high heat to remove this MOSFET. It won't stress the board as much. I'm obviously going to take care of this battery connector here, because I don't want to melt the plastic. The most difficult bit about this, of course, as you'll be well aware, is that the top of the MOSFET is onto the ground plane, so that will take quite a bit of heat to remove it. Of course, you can get preheaters where you would set the board on, and that would bring the whole board up to temperature. I don't have one of those as yet. I don't do enough SMD stuff to sort of warrant the cost of it. So that's warming up, so I'll try that with my left hand now and just bring the temperature up a bit now. Now you should always just keep the airflow, don't keep the airflow in one spot for any extended length of time, because that's what's going to cause you the troubles in the end. We'll keep heating this up. And if I use, oops. Yeah, I was just saying, obviously it's a surface mount device. Once the solder's melted, it's quite easy to just push it around the board. So I was just seeing if there was any sort of movement yet, but not yet. No, so I'll bring the temperature up a bit more now. And this does take a bit of time. You don't want to rush going straight on a really high temperature, because you'll just damage your board, especially on a newer laptop. Like I said in the first part, it's a £2 or £3 component, so I'm not overly bothered about this. If you're going to do this on a more modern machine that's maybe worth a bit more, then obviously you're going to want to take care. Yeah, we're getting there. See what red's come off now. So final bit of heat. Tab. And then from looking at this, it looks like the actual trace has actually come off the board. So I don't know how easy this is going to be to come off now at all. In fact, yeah, it's right, guys. I was just gonna stop this video and scrap it, but I think we'll try and bodge it. Nothing to lose. Yet the MOSFET came off, but over the 8 years or so I've been using it, you can see the track, the copper is lifted from the board. Oops, where did that go? Yeah, so the only place it's actually going to is this resistor here, which excuse me, yeah, it's slightly misplaced, but I think we can maybe just try and stick it on. If it works, it works. If it doesn't, let's say, not lost anything. So I'm going to warm up my iron. Put it on there. Okay, dokes. And we'll get the spare part out. Like I say, got this from topqualitytools.co.uk via eBay, and I think it was about £2.5 including delivery. So and there's our replacement part in perfect condition. And if we just compare those two, I'll put them side by side there, you'll actually see that the original one has suffered quite significant heat damage. It's not burst into flames, but it's gone sort of matted and try and do this without slashing my wrist. You know, it's not it's almost sort of flaking up. You can just see small pieces coming off there. So we'll go ahead and we'll try and let's say bodge this on. It will be a bit of a bodge. It's not going to be perfect, but yeah, we'll give it a blast. Right, I'll just pause the video again and I'll come back to you once I'm ready. Welcome back, folks. So the saga continues. Yeah, obviously the track came off when I was attempting to remove this. As you can see, there was some significant heat damage from the MOSFET, and the actual copper itself has been, well, it's just pulling to pieces. It's really soft and malleable. Yeah, so I don't know if it's actually, you know, degraded or altered the actual structure of the copper, but yeah, it's not good at all. So I've been thinking about how to do this. I saw a video recently on a PCB repair, which involved inlaying and tacking in a replacement piece of copper. I've got nothing to tack on because it's purely the tab from the MOSFET. Sorry, here. So this tab goes onto the copper here, and then there's a long thin strip where the resistor goes on, and I've actually just taken that off because it was misaligned. I've cleaned up the pads with some solder wick. So yeah, I didn't have any copper tape or anything lying around, but I did have this, which came out of a piece of old video distribution equipment. And so what I've done is I've just basically got my sharp knife under the edge. In fact, I'll show you here. There's a vein there, but yeah, you can get your knife under the edge and just peel a bit off. And once it's taken off, I scraped all the solder mask off, and I've been left with a nice piece which is clean, and I've cut to shape, which I'll now put in place. Now obviously this should be epoxied into place, but I don't have any epoxy to hand. So what I'm going to do is, and I know it's not the right thing to do, but just because I've started this video and I want it off my bench, I'm just going to solder this on. So it'll be held in place purely by the components. Now, once I've established that it does work, you know, if it does work, then I won't use this laptop. I'll wait till I've got some epoxy, and I'll come back, take it off, and then make this a proper repair, rather than which is turning out to be a bit of a bodge just now. Right, so I think what we'll do is we'll go ahead and put our resistor back on, which should give us somewhat to tack that piece of copper onto. So, right, how are we going to do this? Right, I think I'll take the copper off first, and then we'll come in with the resistor. Now, before I do anything, I'm going to get plenty of flux on there. I might as well do those pads as well just now. And yeah, where were we? Okay. In fact, it might be easier if I just put the copper on at this point. Okay. Right. So we've got our resistor here, which again I'll put in place. Which again I've cleaned this up. So I'll attempt to do this without getting my head in the way, but as always I usually get my head in. So okay, so that's in place, and all I'm going to do now is get my iron and tin it slightly. See, there's enough flux on there just now, so I should do. And if I just hold the resistor down on, and that is a nice solid joint. Okay, right, so the next thing to do is to tag onto the copper side. So again, nice, fairly generous dab of liquid flux. And then we'll tack onto the copper itself. So we'll give that a quick look. I'll bring it up to camera so you can see. It's not the prettiest of jobs, but yeah. So we've got a nice joint on that side. Maybe a bit too much solder, but we'll not worry about that. And then a joint on there. That doesn't look very pretty, but yeah, it'll do the job. Let's see. This will be coming off if it's working okay. This will be coming off. So the next thing we're going to put on now is obviously our MOSFET itself. So the way I'm going to do this is, again, I'm going to put a bit of flux on there. Maybe a bit too much there. So we've got our flux on there. I will bring the MOSFET in. Hopefully you'll be able to see this. Tin the iron, small amount of solder on there. Align this up and tack that side. Okay, this side. Solder. Yep. Again, a quick inspection. Yeah, again, maybe a bit too much solder, but never mind. Okay, and then last but not least is to put the tab end on. So, already put plenty of flux on there, so this should come on quite nicely. So, tin with iron. This needs quite a bit of heat because of its location. And that should do it. Okay, well that really isn't pretty, but it's a means to an end. What do we see? Maybe just drag it again to the other side. Flux out that float. That's better. Okay dokes, right, so all important bit of course is to clean up that flux. Between you and I will be amazed if this works. I'll try and get as much of that off as possible. And then we'll have a look at the job we've done. So, just get a bit of lint-free cloth, these little tech wipe things, and then we'll inspect what we've done. So there's the joint. So we've got our resistor in place, which is onto the existing copper, which is good. We've got a replacement piece of copper, which the MOSFET's tagged onto, and then our actual leads onto the board. Now, I'm half inclined if this does work. That is a fairly solid. It's a fairly solid joint, because I've put quite a bit of solder on there. It's given that some rigidity. So it may be that taking off and epoxying it on might not actually be required. But I think, let's say I'm not a professional, but I think a bit of pride in your work is important. So I think I probably will take it off, but we'll see how it goes. So now what I'm going to do is I'm going to turn off, go and reassemble it, and we'll see if that's solved the problem. See you in a bit. Welcome back, folks. Well, this is the last part of this repair video on the Aspire 6530G. I like in my other videos, or all my videos, as far as I can do, is to do it all in one take. Obviously this repair's had quite a few lengthy processes where I've had to stop the video, but what I can assure you is that this is the first time I'm applying power to this after repair. So I'm either going to look like a legend for fixing it, or I'm going to look like an absolute idiot for bodging a repair that didn't work in the end. So only time will tell. But like I said, if it works, I'll be pleased, because it's going to cost me, it's only going to have cost me £2.50, $4, whatever you want to call it. And I will have my workshop laptop back up and running, and I won't have to bring in my expensive Toshiba. And if it doesn't work, then I can always strip it for parts and use that in other projects. So yeah, I suppose without further ado, we'll apply power. So I hope you've all got your fingers crossed. For me, anyway. Here goes. And we have a power light. So something's obviously improved. But will it turn on? It certainly sounds like it's booting. And yes, it is. Cursor on the corner there, and there we can see the Windows 10 logo. So yeah, that is booting. That flashing is just the camera. I don't know if it's a refresh thing or something, but it isn't flashing as I'm looking at the screen. So yeah, welcome. Quite impressed with that, or not impressed, but quite pleased with that repair. Would I do anything differently next time? Yeah, probably. I'd probably have some epoxy on hand and do a proper repair on that. Like I say, I will probably strip this down. Just turn on. Yeah, I'll probably strip this down again and take that back off and make a proper repair on that and epoxy the copper down, and maybe get some solder, solder mask to put over the top, or some sort of conformal coating. But yeah, just a coating to stop that copper from oxidising and stuff. I've had this for 8 years. Do you know what I mean? If it breaks again, it definitely will get binned. I don't think I can see myself fixing it again. But yeah, pretty happy with that, and hopefully you've enjoyed it and maybe learned something. maybe learn how to do something, maybe learned how not to do something, but it might help someday, and that's the reason I do these videos. I get plenty of help from YouTube videos, and you know, I don't like to use the term giving something back, but you know, if it helps just one person out, then that'll make me happy. Anyway, that sounded a bit deep and emotional, so on that note, I shall bid you adieu. If you enjoyed it, please give me a thumbs up, and if you enjoy my videos, please subscribe, and I'll see you again soon with another video. See you later, bye bye.